Yes, good day. Welcome to my physics channel. Um, we once again we will be practicing past exam papers, and the reason why we do this is because we can only pass physics if we practice a variety of questions on any particular topic, because doing that helps us to understand the topics better. Right, so sit back, relax, and enjoy the lesson in the comfort of your own environment. You could be at home. Yes. Right. Today's topic is on net force and momentum. I have a question here which I think is a good one, which covers also the South African IEB syllabus and NSC syllabus um, on net force and momentum. It is from the Cambridge June 2023 paper. Yeah, it was paper 2, variant 1. Good. Right. So the setup is as follows. There's an object there which is being pulled by a force X, right? And it's a variable force X, and there is the friction. Obviously, friction opposes the motion of the working in the opposite direction. There's an average frictional force of 2 newtons on the force. And then they went on to plot a graph of momentum in kilograms meters per second. It may not be very clear. Kilograms meters per second. Momentum is in kilograms meters per second is plotted against time. Now, students, once again, we want to be able to understand what these graphs mean. That is the key. So if you see a straight line, it means the momentum is increasing at a constant rate, right? And then the momentum is not changing, right? Right. Now, there's something that we know from the definition of net force, which is also called Newton's second law, which is another way of stating Newton's second law. What does it say? Right? Anyone who still remembers how to state Newton's second law in terms of momentum? Anyone? Good. Right. So Newton's second law, you can say that it is equal to the rate of change of momentum. Okay, let me write that down. What it means. So if you can write Fnet F sub net is equal to rate of change of momentum. Right. The rate at which momentum changes. So it is rate of change of momentum. Right? So, which is, you can really simplify this one as the final momentum minus initial momentum over change in time. Right? So if you look at the graph, there's momentum on the right hand side and the time on the x-axis, momentum on the vertical axis, and time on the horizontal axis. So this graph is not dissimilar from, remember we've done a graph of velocity versus time, and the gradient of a velocity versus time graph, yeah, which is almost similar in velocity meters per second or versus time. The gradient of that, we said it is acceleration. So the gradient of a momentum versus time graph is what we call net force. So, in other words, from Newton's second law, you remember, if, for example, you put momentum is mass times velocity, yeah, that could also help us. Let me just do the derivation of the formula F equals to ma. Although what we need actually is just this to be able to define to state Newton's second law in terms of momentum. All right. Anyway, let me start by stating Newton's second law in terms of momentum. That was the first question from the Cambridge paper, which said state Newton's second law. So you say net force is equal to rate of change of momentum. This is change of momentum over time. So If this formula is on your formula sheet, it's an open book exam. You can clearly see this is the rate of change. And on the graph, net force is the gradient of a momentum versus time. So you are going to find the gradient. Obviously, the gradient here from 0 to 4 seconds, the gradient there from 0 to 4 seconds is a constant. Right? Remember, when you differentiate a straight line which is at an angle, you get a constant. And if it is forward like this, the gradient is positive. If it is flashing that way, the gradient is negative, but it will be a constant. But the gradient of a horizontal line is 0. So which means we expect that the net force here from 4 seconds to 6 seconds, the net force is 0. Yes, you will see that will help you to solve the problems that they as I'll be reading the questions as we go along. So here I just wanted to, so we have defined momentum in terms of net force, and then here I just wanted to show how the formula for net force, momentum is mass times velocity. Mass is not changing, so the velocity is Vf there minus m, the velocity is Vi there. This is momentum, initial momentum, final momentum over delta t. If you take m out there, you end up with Vf minus Vi over delta t. And now, if you look at that expression now, you know that from the Newton's, from the equations of motion, Vf minus Vi over delta t is acceleration. Yeah, you know that from the first equation of motion. So therefore, Fnet is equal to Ma. That's why sometimes Newton's second law is expressed in terms of this formula. Yeah. Okay, good. Let me clear the board and then continue to the next question. Right? The next question said, determine the resultant force at the time t equals to 2 seconds. And determine the resultant force at the time t equals to 4 seconds. Right. Essentially, what you are doing here is you can use this whole thing to find the net force there. Because it will be constant here. Here it's a straight line like this. Remember? Good. Once you get that, so we don't really need, unless we knew, if we knew where this one, I'm not sure exactly where it was, but I knew it was definitely that the 6 there. 6 kilograms meters per second momentum is measured with 4 seconds. So we can use the bigger, remember with accuracy when you're doing gradient, change in y over change in x. Yeah, can we see that? From 0 to 4 is the change in x. It will be 4 seconds over 4 seconds. Change in y is 6. So you can say gradient equals net force, which is equals to your change in y, 6 minus 0, 6 minus 0 over change in y over change in x, 4 minus 0 over 4 minus 0. So we get 1.5 is the gradient of this line. So the gradient of that line is also certainly the net force. So you just have to put n. So you can say net force, you find our answer. Net force is 1.5 newtons. Right. That is the net force. Then the next question they ask is determine the value of the force x during the period 0 to 4 seconds. We know the net force, so we can find what x is. Right? Net force, by definition, again, I'm repeating, it was on another video, is the sum total of all the forces acting on the object. Let's add them now. So we have got x. We're just trying to find the net force, x plus the frictional force, which they said there was an average frictional force of 2 newtons, but it's going to be left. So to the take to the right is positive. So it will be plus minus 2 will be equal to your net force. This is net force. We've calculated by definition the sum. Right. So it's going to be equal to 1.5. So we can say x minus 2 is equal to 1.5. Others, they just know that Net force is forward. Any other force going opposite direction minus, and then you get your net force. But it's better to apply your knowledge everywhere, so that you know that by definition net force is the sum. Then you see x translated to that side, 2 plus 1.5 is 3.5 newtons. So it means that this variable in force x was actually 3.5 between 0 and 4. That's why it is a straight line. And then, like we said, the gradient of an horizontal line, in a horizontal graph, like that is 0. So it means the net force is 0. So how, if the net force is 0, you can apply, find what x is again. So you just say x is plus minus 2 gives us a net force of 0. So let me write it. We can write at the top there x. So to find the value of x there between 4 to 6 seconds with straight line, we say x, plus x from that plus our friction, which is in the opposite direction, gives us a net force of 0, because the gradient of momentum versus time graph is that. Therefore, x is equal to 2 newtons. We translate it to that side, becomes positive 2. Right. Then the last thing that I want to say is they also asked to draw the x. Let me put it at the top again so that we can all see. They say from 0 to 6 seconds, draw a graph. This is chemistry paper of x, the force against time. Let's say this is 6, this is 6, this is 4, this is 2, this is 0. Right. So we already calculated from 0 to 5, the force was 3.5. So immediately it was not changing, it was 3.5 constant there, 3.5, and 4 is here. So this is just need a straight line. This needed dotted lines, right, up to 4. No, up to 4. Yeah. Then from 4, right, we found that we found that it was 2 newtons, because the net force was 0, 2 minus 2 was 0. So you want to, this is 2, okay, this is 2, 2, 4, this is 6, 8 newtons. Don't forget to put the units time in seconds, right? So you can plot now from there, it was like this. So you get your marks, so this would be your graph. That is all that they needed. Right. Thank you very much. I hope you enjoyed this lesson. Don't forget to email me for any questions that you may have. My email address is this one, my first name, send them together at gmail.com. You may want to join our maths and physics classes. Right. Let's push this. Thank you so much. Well done.